So we have looked at the DIT, right? DIT FFT. Now what we saw was with that structure. I'll just open that structure. Let me open this structure. Okay. So what we have seen here with this structure is that if you look at every stage, if we look at this particular structure, right, if we look at every stage, there are like n multiplications in every stage. So in this case, for example, we are calculating 8-point DFT. So 1 2 3 4 5 6 7 8 8 in this stage, 8 1 2 3 4 5 6 7 8 and n multiplications, right? 8 in this stage and 8 in this stage. So basically the total number of computations turn out to be n log 2 of n. Yes, so this is what we have seen. There is a way in which we can actually optimize this and make it, turn it into the total number of computations, the complex multiplications, to be n by 2 log 2 of n. How we can do that is we can use the property of the WKN of n. So let's see. Okay, let's look at the 2-point structure, and then we'll extend it to 4-point and the 8-point structure. Okay, so the 2-point structure, let's say, is this. This is your 2-point structure. Let me draw it properly again. So this is your x of 0, this is your x of 1. Okay, so the 2-point structure here was initially was given as something like this, right? Okay, so 2-point structure, this was W0 of 2 and this was given as W1 of 2. Okay, and this was given as your output, which is 0 and 1. Now I can redraw this structure. What we have seen is W0 of 2 and W1 of 2, right? So if you draw a structure, if you draw a circle, okay, if you draw on a circle, so this is your W0 of 2, this is my W0 of 2, and if you look at it, the W1 of 2 is actually this guy, which is always a negative of the W0 of 2. Okay, if I have to draw on a circle W0 of 4, how it will look like is, if you look at this, this will be W0 of 2, 0 of 4, sorry, this will be W1 of 4, this will be W2 of 4, and this will be W3 of 4, right? This is how it looks like. So if you see, for every W there is a W on the other side. So what it means is I can actually let me just, yeah, so I can actually optimize this structure. So let me optimize this structure with only half the number of multiplications. So let me just see this. Okay, so think about this. Okay, so this is your, so what I'll do here is I'll multiply this guy with a W0 of 2. Okay, I'll multiply this guy with a W0 of 2. Okay, and from this point what I will have is, this is 1, this is coming in here like this, this will be -1. Okay, and what you will have is only one computation now, one complex multiplication. This is a negative. So if you look at this, right, W0 of 2 is what I am multiplying both these guys. Okay, x1 is multiplied with w0 of 2, and only thing I am changing the sign here to make it convert it into a w1 of 2. So w1 of 2 is a negative of w0 of 2, right? So I change this sign and I get my 2-point computation done with only one multiplication now. Okay, so this is your 2-point computation done with only one multiplication. Now similarly, look at the 4-point structure. Okay, we'll have a look at the 4-point structure, which will be like, let's say, go to the end, and let me just redraw this structure. Okay, so let's draw a 4-point structure now. So you have this guy here. Okay, so this is your 4-point structure, let's say. So you know that we start off with like a 2-point structure and then go towards the 4-point structure, right? So here what I'll do is, this will be w0 of 2, this will be w0 of 2. Okay, so let's say this guy here. Okay, so now let me draw this. Okay, so this is a -1, this one is here, this is a -1. So this, you start off with like x of 0, it's out of place, out of sequence, so this is 1 and this is 3, right? So this will be a 2-point structure. Now the 4-point structure will look like this. Yeah, so the 4-point structure, yeah, so first I have to do the multiplication here. This will be w0 of 4, this will be w1 of 4. Okay, so this guy here will be, or I can just say w0 of 2 and yeah, so that's okay right now, so that's fine. So this guy here will be now we do a Control Z. Okay, so this is what you have. So this is your second part. So this will be -1 and this will be -1. So this in short will give you the 4-point output. So this value will be x of 0, this value will be x of 1, this value will be x of 2, and this value will be x of 3. So this is what will be a 4-point structure looking like. Initially you had a 4-point structure which looks like this was your w0 of 4, this was your w1 of 4, this was your w2 of 4, and this was your w3 of 4. So what we have done here is this W0 of 4 is exactly on the other side of W2 of 4, right? So if you draw a circle, what I have done here is this was your original one. So now what I have done here is, what we have done here is, if you look, if I just so draw a circle here. So if you look at this guy, what we have done here is, this is your W0 of 4, this is your W1 of 4, this is your W2 of 4, and this is your W3 of 4, right? So let me just draw it properly. This one, I don't need this. So this one is your W0 of 4, this one is your W1 of 4, this one is your W2 of 4, this one is your W3 of 4, right? So this, if you see, this branch here, this node gets multiplied with W0 of 4 and W2 of 4. So what I have done is, what I have preceded this with a W0 of 4, and W2 of 4 is minus 1 of W2 of 4, right? So I don't need this computation at all. I don't need this computation at all. So I can multiply this with a W0 of 4 and then just subtract it, okay, from this guy. So that's one computation will be reduced, right? So same way here, W1 of 4 gets multiplied with this node, and W3 of 4 gets multiplied with this node, right? So instead of that, I can precede W1 of 4. W1 of 4 and W3 of 4, they are in opposite direction. So they have a negative, W3 of 4 is minus of W1 of 4. So I multiply this with a W1 of 4 and get a negative sign here. So I don't need this multiplication here now. So this is one change which we do. And then the number of computations in this case reduced to 2 per stage, right? So n by 2 per stage. How many stages? Log 2 of n. So this is how you can reduce your complex multiplications. Okay, so this is also a DIT structure. You can replace the previous DIT structure with this now. Okay, here there is a reduced number of complex multiplications. So if you want to get the 8-point structure, what we can do is we can have this structure here. Let's say the 8-point structure will be very similar. Only thing, the change will be, so it's better. So this is the 8th line. Okay, so now what you will be having here is, first we start off with a 2 point. So this will be multiplied with a W0 of 2. So you have this point here. This is your 2-point structure. You know that this is x of 0, 2, 4, 2 and 6, 1, 5, 3 and 7. Okay. Yeah, so this is W0 of 2, this is W0 of 2, okay. This is W0 of 2. Now the next step is I'm multiplying minus 1, so this guy will be like okay. So this is what I get. This is a minus 1. So this comes out to be like the 2-point DFT now. This 2-point DFT has to be now converted into a 4 points. So the 4 points will be, this will be multiplied with W0 of 4, this will be multiplied with W1 of 4. this will be multiplied with W0 of 4 and this will be multiplied with W1 of 4. So you'll get these points now. Okay, so now this guy will be going here. This guy will be going here. Okay, so this is my 4 point done now. This is my 4 points. This will be -1, this will be -1, this will be -1, this will be -1. Okay, so get your arrows done. So these are your arrows. This, okay, now this arrow, same thing will come here. This guy, okay, so these are your 4 points now. 4 points have to be now separated into 8 points. So 3 are actually converging into 8 points. So this is your 4 point. Now the 8 point starts. So this guy has to be multiplied with -1. These 4 guys, W0 of 8, W1 of 8, this is W2 of 8, and this is W3 of 8. They are actually right diagonally or the on the opposite side of the same circle. Okay, so they are like multiplied by -1 factor. So now this here will be okay. So now this is multiplied by -1, this is -1, this is -1, and this is -1. So they converge here. So this guy, they converge. So now if you see this, right, this is your 8 point output. So this is x of 0, decimation in time, so this will be in order, right? So if you see the total number of complex multiplications, 1 2 3 4, 1 2 3 4 and 1 2 3 4. So now 4 computations per stage. So it's like n by 2, which is 4 into the number of stages, log 2 of n. It's 4 into log 2 of 8. So it is 12, right? 12 computations, complex multiplications here per. So this is how you can generate your structure. So if you fill in the values here, you can actually then go ahead and solve this. Okay.